In this exciting tutorial, we're going to learn how to use the JavaScript Gamepad API to move this orange player on the screen using a controller. This is Coding with Adam, and let's get to the code. If you enjoy my videos, please subscribe, like, and share. On the left-hand side of the screen, we have the final solution that we're going to be building in this video. On the right side, we have the fully functional gamepad tester that we built in a previous video. You can find that tutorial linked in the description. I'm going to be using the gamepad tester to show you the buttons that I press as I move the character on the screen. In this simple game, we're going to be using the directional pad to move the character left, right, up, down, and even diagonal. And we'll also be able to use the analog stick to move the character left, right, up, down, and diagonal as well. Lastly, we'll also be using the face buttons in order to change the color of the character depending on the button that is pressed. For this project, we're going to be using JavaScript and a little bit of HTML. We're going to be using VS Code as our IDE. And on the right-hand side over here, I just have a browser open to the project that we'll be working on. And then below, I have the controller so you can see what buttons I'm pressing, and I'll have that URL in the description. To get started with this project, we're going to create two files, an index.html and an index.js. In the index.html, we're going to create the boilerplate HTML by putting exclamation and then hitting tab. For the title, I'm going to go ahead and call it Gamepad API. Inside the body, we'll go ahead and add a canvas. We'll give it an ID of game area. Let's add a tiny bit of styling. So we're just going to create a style tag here in the head, and we're just going to style our body. We're going to remove all the margin and all of the padding. So we'll just give this 0 pixels, and padding will give 0 pixels as well. Let's add our script tag right after our styling. We'll set the src equal to index.js. And then really important, because we have our script tag in the head, we have to put the defer attribute, which will cause this script to run after all the HTML has loaded. Next, we'll open up our index.js, and inside here, we're just going to do a little console.log that says hello, just to make sure that our code is running as expected. To run the code, we're going to be using an extension called Live Server. In VS Code, click on the Extensions tab and search for Live Server, and then go ahead and install that. Once you have it installed, you can go back to your index.html, right-click on it, open with Live Server. It should then open up in your browser. You'll notice that the page is blank because we have a canvas, but it doesn't have a width or height or any color to it. However, if we right-click Inspect and we go to the Console tab, we'll see that it printed out our JavaScript that said hello. If at this point you don't see hello, go back to your script tag in your HTML and make sure that it's set up properly. Now we can go back to our index.js and start to set up our game. The first thing we're going to do is we're going to get our canvas. That's where we're going to be drawing the game to. So we'll look for the element ID, and we're going to look for game area. If we go back to our index.html, you'll notice that we named our canvas game area with the ID. So we get it by game area over here. Then the next thing we're going to want is our context, often abbreviated CTX. And we're going to go to our canvas. We're going to say get context, and we're going to ask for a 2D context. This is what we're going to be using to actually draw to the canvas. Then we're going to set up a few variables. We're going to set up the player width and height. They're going to be the same value since it's a square, and we're just going to default that to 0 and dynamically determine that based on the screen size. And then we're also going to set the player X position equal to 0 and the player Y position and default that to 0 as well. Our player also has a color, and the default color is going to be orange. However, we can change the color depending on the button that we're pressing. And then there's also a velocity, and we're also going to make that dynamic depending on the screen size that we have. Before we continue, let's go to our index.html, and we're temporarily going to set up a style for our canvas. We're going to give it a background color so we can see it on the screen. I'm going to give it the color blue-violet. Choose any color that you like. And now we can see our canvas on the screen. Inside of our index.js, we're going to go create a function called setUpCanvas, and it's going to set the canvas width and height, and then items related to it, like our player width and height, based on the size of the window. Let's start by setting up the canvas width and height. So we'll set up the width, and we're going to make that equal to our window.inner width. And we're going to do the same thing for the height. So I'm going to duplicate that line, put height, and for the inner height of our window over here. Then if we save that, you'll see no change because we haven't called the function. So we'll call the function setup canvas and click save. And now we can see that our canvas is taking up the entire screen. If I go ahead and take our window and I resize it, you can see that our canvas doesn't change size. In order to handle this, what we're going to do is we're going to subscribe to an event called Resize. This event lives on the window, so we're going to add an event listener and we're going to listen for resize. And when resize happens, we're going to go ahead and call the setCanvas method. We'll go ahead and save that, and this will refresh automatically since we're using the live extension server. Now, if I grab that window, you'll see that it continues to resize and change shape. It's very quick. We can't even tell. Let's go ahead and just set up a couple more variables. We're going to set up the player width and height, and we're going to make that equal to our canvas dot width times 0.1, so it's about 10% of our width. And then our velocity, we're going to set that equal to our canvas dot width times 0.01 for about 1% of our width. And then we'll set up our player X, and we're going to make that equal to our canvas.width, and we're going to minus the player width and height from that, and then divide those numbers by 2. And then we're going to set up our player Y, which will be very similar. We're going to take the canvas height and we're going to minus the player width and height and then divide that by 2. And this will center our player on the screen. Now we can go ahead and set up our game loop. The game loop is going to be continuously drawing to the screen. We're going to use request animation frame, which will call the game loop when it has a new frame that can be drawn to. And in order to prove that this is working, let's go ahead and put a console log over here, and we'll just type out game loop. And then below, to get this going, we're going to put game loop and call it. And then we'll open up our console, we'll go to the console, and we can see it's calling game loop over and over. So that is working. The first thing that we want to do in our game loop is call clear screen. We'll go ahead and define the clear screen function. I'm putting it above the method, but it can go below or anywhere in the file. We're then going to use the CTX, which is kind of like our paintbrush and allows us to draw to the canvas. I'm going to use a hex color code here. This is like a dark gray. And then I'm going to say ctx.fill. And to clear the screen, we're just going to start from point 0, which is in the very corner over here. And then we're going to draw over everything. In order to do that, we're going to use the canvas width and then the canvas height. And this will cover the entire screen. Now you'll see that it changes to this dark gray color. With each call to game loop, it's going to go ahead and clear the screen. The next thing that we're going to do is draw the player, and we'll define that function just above. And that function is going to look kind of similar to our clear screen. We're going to have a ctx.fill style, except we're going to set that color to the player color, which by default is orange. And then we're going to use ctx.fill rectangle, and we're going to give it the player X position and the player Y position. And then we need to give it the width and the height, which those values will be the same thing since we're drawing a square. And now we have our player on the screen. They're centered on the screen. And if we drag the window, it's going to reset the player position. For example, if the player had moved up into the corner and we change the window size, it would knock them back to the middle. Obviously not something you would do for a real game, but it's quite useful in this demo that we have. Next, we need to be able to handle input from our controller. So we're going to need a couple more variables that we're going to assign here at the top of the screen. We're going to go ahead and create a controller index. This is going to be the index of the controller. Make sure to set this to null. Then we're going to do left press. We want to know if left press is being pressed. If it isn't, it's set to false. We'll do the same thing for right, and we'll set it to false. And the same for up pressed is equal to false by default. And guess what? Down pressed is also set to false. In order to connect to our controller, we're going to be using the JavaScript Gamepad API. The JavaScript Gamepad API provides two events, one for when a controller connects and another for when a controller disconnects. For more details, I recommend checking out the MDN web documentation on Gamepad API. Let's go ahead and implement the connect and disconnect event for a controller. And we're going to do that over here next to our other events. So we'll do a window.add event listener, and we're going to add the gamepad connected. Make sure to spell that correctly. And then we're going to give it an arrow function that's going to take in an event. We're then going to take our controller index and we're going to assign that to the value of the controller that was just connected. And the way that we're going to do that is we're going to the event gamepad.index. And this is the index of the connected controller. The assumption in this little game is that there is only ever one controller, so the last controller that gets connected will be the connected controller. And then we just need to implement the disconnect event. So all we have to do is change our event listener over here. So instead of listening for gamepad connected, we're going to listen for disconnected. And when the gamepad is disconnected, we're going to go ahead and set the controller index to null. Let's go ahead and confirm that our connect and disconnect is working properly. Inside of our connected event over here, we'll just go ahead and add a console.log and we'll type out connected. And then inside of our disconnected, we'll just type disconnected here. Then we'll go ahead and check that by opening up our console, and then we'll push a button on the controller and it says connected. And if I disconnect my controller from Bluetooth or unplug it, you'll get a disconnected message. Now that we know that we can connect and disconnect our controller, we can go down to our game loop and we're going to call a new function that we're going to be creating called controller input. And we'll define that function above over here. The job of the controller input is to go ahead and get the gamepad and then assign the correct value depending on the buttons that are pressed for the left, right, up, and down pressed. The very first thing we need to do inside our controller input is check if we have a value for our controller index. And we're going to check that it's not equal to null. Then what we can do is we can go ahead and get our gamepad using that controller index. And we're going to get that from the navigator get gamepads, and that's going to give us a list. And inside that array, we can pass in our controller index. Next, let's go ahead and console log our gamepad so we can understand what that object does and how it works. If we take a look at our console over here and we push a button on our controller, it's going to print out a lot of gamepads because we're in the game loop. But if we stop it, we're going to see there's an ID that describes the name of the controller. There's an index, and the most important part, the buttons. It is an array of buttons, and each button tells us whether or not it's being pressed, touched, or has a value, which is a number between 0 and 1. If we go ahead and press these buttons on the controller over here, you're going to see that the value changed to 1 over here in the corner. Now the trigger buttons are variable, so when I go ahead and press the trigger, you're going to see this little meter go up slowly, and it's a number between 0 and 1. Now the other important part inside the gamepad are axes. They represent these sticks. Each axis is going to represent a direction, either left and right or up and down. Now 0 and 1 inside our axes array represent this first stick over here, and then 2 and 3 represent this stick over here. The first value in that array over there is going to represent the stick movement from left to right. So if I go all the way left, it's going to be -1, and if I go all the way right, it's going to be 1, and then the second one is for up. So it's -1, and then when we go down with the stick, it is 1. And it's the same thing for this stick as well, using axes 2 and 3. Now inside our controller input, we can go ahead and get our list of buttons from the gamepad. Now with this list of buttons, what we can do is we can go ahead and set our left, right, up, and down pressed values. And the part of the controller we're focusing on right now is the direction pad. So these values over here. We'll start by setting the up pressed, and we're going to go to our buttons array, and for up, if we push up on our controller, we're going to see that it is 12, and we'll put 12 over here. And then we want to know if it's being pressed, which is a true or false value. So we look at the pressed property, and then I'm just going to duplicate these lines over here, and we'll put down, left, and right. And then we just need to put the right indexes. So if we push down, you're going to see it's 13. And then for the left and right, I can tell you that it is 14 and 15. One thing you can do real quick is open up your console over here, just mash a few buttons on your controller, make sure there's no errors. It says connected, so that means we're in a good state at the moment. Now that we got the controller input, the next step we need to do is based on the controller input, we need to update the player. Down in our game loop, we're going to call a function called update player, and then we'll go ahead and define that function. Inside update player, we're going to be doing two things. One is moving the player and the other is changing the player color. Since we're doing two distinct things, we're going to create two functions. We're going to have a move player, and then eventually we're going to implement the change player color. For now, we won't implement this, but we'll create a move player function. We'll define that above. And then inside move player, let's go ahead and do our first check. What we're going to do is we're going to check if the up button is being pressed. If the up button is being pressed, we're going to take our player's Y position and we are going to minus equal the velocity and save that. So if our position over here is position 50, let's say, and we want to move something up the canvas, well, we're going to be moving towards 0. So we have to minus that number. Now let's go ahead and try this out. I'm going to close the console over here. And you can see if you look at my controller over here, you can see it changes red and the character moves up. And we can't bring the character back down because we haven't implemented the down. So let's go ahead and implement the down pressed. The down pressed is the opposite of our up press. So we take our player Y and now instead we do a plus equals our velocity and save that. Now on my controller, I should be able to press down and up, and you can see that down on the controller. I'm pushing those buttons and our player is moving properly. Let's go ahead and implement left and right. For the left and right, very similar. We're going to grab our left pressed. And if you're moving left, you're going to be moving negative. So we're going to take our player X and we're going to minus equals our velocity. Let's just copy our if left pressed, and I'm just going to paste that, change this to right, and then change this over here to a plus. Well, let's go ahead and test this out. I can move left, right, up, down, and I can even move diagonal if I push two buttons at the same time. Next, we're going to go ahead and implement moving our player using the left stick. We'll start by creating a variable called stick dead zone. The dead zone will affect how our player can move using the stick. If we leave it at 0.4, we can move diagonally. However, if we set it to 1, we're only allowed to move left, right, up, and down, but we can't move diagonal using the stick. Next, we're going to go ahead and get the left and right value from the gamepad axes. So we'll use the gamepad, and the first axis is going to describe the left and right movement. If we move our stick over here to the left, you're going to see it's -1. If we move it to the right, it's going to be a positive value 1. So that means we can go ahead and do an if statement that says if the left right value is greater than or equal to the stick dead zone, we can go ahead and move in the right direction. So right pressed is equal to true. Otherwise, we can do an else if statement that says if the left right value is less than or equal to the negative value of the stick dead zone, then we can move in the left direction, and we'll set left pressed to true. Let's test this out. We're able to move left and right. Now let's go implement up and down. For our up down, we're going to do the same thing as our left right. We're going to create an up down value, which is going to be equal to our gamepad.axes, and we're going to look for the second value, and then we're going to take our up down value, and if it's a greater than or equal to the stick dead zone, that means that down is pressed, and we're going to set that to true. If we take a look at our controller over here, when I press down, you're going to see that axis 1 over here goes to a value of 1. And then in our else if, what we're going to do is we're just going to check if the up down value is less than or equal to our stick dead zone, and make sure to put a negative in front of that. Then that's going to mean that we're going up. So the up pressed will be equal to true. Now we can go ahead and test this out. So with our stick, we should be able to move up, down, left, right. And because of the dead zone that we have set right now, we can move diagonally. A really interesting thing about the sticks is that if we configure the sticks dead zone to be a different value, for example, we change the value from 0.4 to 0.8, we get a different behavior. At 0.8, you're only able to move left, right, up, down, and you can't move diagonally. This is perfect for games like Pac-Man or anything that doesn't require a diagonal movement. The very last thing that we can do is program our face buttons to change the color of our player, depending on the button that's pressed. Let's go ahead and add a few variables for this. We're going to scroll back up to the top of the screen, and right below or up, down, left, right pressed buttons. Let's go ahead and define a few more buttons. We're going to have blue pressed, and we're going to set that to false. Then we'll also define orange pressed, and we'll also define that to false. Then let's add a red pressed and a green pressed. Let's go down to our controller input function. Inside our controller input function, we'll put this code at the very end. And what we're going to be doing is we're going to be taking all our buttons and we're going to be assigning them to the value of a particular button to see whether or not it's pressed. Now, these can be any buttons on the controller, and the buttons I'm going to decide to use are the face buttons over here. And we're just going to get those values. If I just mash all of them at the same time, we can see exactly which values they are. They are B0, B1, B2, and B3. So arbitrarily, it starts from index 0. All I have to do is put 0 over here, and if it's pressed, then we're going to get the red color. And we're going to do the same thing for all the different colors that we have. So let's do that for blue, and I'm going to put 1. For orange, I'm going to go ahead and put 2. And then we just need our last one, which is going to be green. And I'll just set the index to 3 and then change this to say green. Now, it's not going to do anything yet. We're grabbing the values and we're determining whether or not these have been pressed. Will be handled in our update player. Taking a quick look at our game loop, you can see that we take our controller input and then we update our player. If we go to the update player method, we mentioned that inside there, we're going to be responding to moving our player. And the other thing that we're going to do is change the player color. So now we can go ahead and create this function. We'll create this function just above the update player function. Inside this function, we're going to do a series of if statements. We're going to check if any of these buttons are pressed, and then we're going to change the player color. So let's start with the blue pressed. If blue pressed is true, we'll set our player color equal to blue. Then we'll do the next color. If red is pressed, we're going to go ahead and set the player color to red. Then if orange is pressed, we're going to go ahead and set the player color to orange. And lastly, we have our green pressed. We'll set our player color to green. Let's test this out by pressing the face button values, and you can see the color is changing. I can also use the directional pad and change my colors while moving around. Same for the stick, and everything is working perfectly. I hope that you really enjoyed this video and learned a lot about the Gamepad API and building a really simple game with it. To learn more about the Gamepad API, check out my tutorial on how to build this awesome little gamepad tester. If you enjoyed this video, smash that like button, subscribe, and hit that notification bell.